Welcome to this short tutorial of Fluidit Sewer. In this tutorial I will show you how to create your first model in Fluidit Sewer. Let's zoom into Helsinki since it's a familiar place for me. In the sewer models, the water always goes to the gravitational direction. Of course you can have pumping stations, but mainly the water flows to lower elevation. So let's start by adding some manholes and pipelines to our model. On the top level menu I will select Add Conduits tool. When I have selected it, I will see a cross in my map view. If I left click, nothing will happen, but if I press down Ctrl key and left click, the program will create a manhole in the location and start drawing a pipeline. Now if I press left button without pressing down Ctrl key, the software will create a vertex in the location of the pipe. If I press down Ctrl key again and left click, it will create a new manhole and continue drawing. Let's add few manholes and pipelines here in my model. There. If you're ready, then press ESC and press ESC again and you will select the selection tool, which is the most convenient tool when you're moving around in the map. Okay, now we have few manholes, few pipelines in our model. If I look at the contents of a manhole, for example this first one that we added, you can see that the elevation is 0. It's the same for all of my manholes at the moment, because I don't have a digital elevation model that could have been used to fetch the elevation automatically. For demo purposes I will put elevation of 10 meters to this first manhole, so it means 10 meters from the sea level, and it's the bottom elevation of the manhole. And to the last manhole I will put 2 meters, so there's a difference of 8 meters in our small model. If I select the first manhole and the last manhole by pressing down the Ctrl key, and I can find the route between these manholes, I can use from the right click find best route. Now I can see in the profile view window what type of profile my small model has. The first manhole is in elevation of 10 meters above sea level, and the last one is 2 meters above sea level. If you don't have this profile view window active, you can find it from the top level window and profile view window. And as I showed in the earlier introduction video, you can drag and drop these windows anywhere you like. You can have as many profile view windows or other windows as well. But yeah, let's close it for now. What I would like to do now is to have a certain slope between these two start and end manholes. I can use a nifty tool by pressing right button in the map view when I have selected the pipeline, and then interpolate elevations, and I will say interpolate between start and end. So the program will automatically interpolate with a constant slope the pipeline between the start and end node. Now it looks kinda nice. But I can still see that the depth of my manholes is 0. So I want to add a little bit depth to those manholes so they don't overflow. So on the properties window, there's component type drop down menu. With this you can narrow down your selection. So I will select junction and press that button so it narrows down the selection to only the junctions in my model. Now I can modify the attributes of all the junctions at once. So I will put a depth here for 2 meters. Now you can see in the profile view that all my manholes are 2 meters in depth. Right. Okay, then let's look at our pipelines. I didn't have any material specified for these, so they are in the template attributes. What I would like to do is to put some type of proper material to those. So first I will load Finnish material pack. So this is a Finnish localized material pack for the materials that are used in Finland. The materials are found under model menu, materials, and these are fully customizable to suit your needs. But I will use these at the moment. Okay, I will select all of my pipelines. Once again using the component type narrowing down. And put same material to all of them. Let's put 160 PVC pipe. There. Now the program fetches the diameter and the roughness from the material library. And by the way, if you see profile view like this kind of messed up, it's because that you have to select the pipelines in right order or use the route selection tool. So it will draw the pipelines in correct order to profile view. Now I have material in my pipelines. Then we should add some inflows to our system. So as you know, in the sewer system, the inflows come from the consumers or the leakage to the network. So let's add few consumers or wastewater producers in our network. On the top level menu you can see add inflows. I will add few here. They are those purple dots that are not that visible at the moment, so I will take off the background map by double clicking the name. And now you can see these purple dots here. Let's add some daily inflow to these. So I will say that these 3 will produce 50 cubic meters per day, and maybe these 3 here will produce 75 cubic meters per day of inflow. And as we know, the inflows varies throughout the day, so we should add a daily variation to these inflows. From the model menu you can find patterns that can be used to vary the inflow amounts throughout the day or throughout different days or even months. So I will create a new pattern here. Inflow. And one nifty thing is that you can copy paste quite easily values between our software and, for example, Excel. I have a pattern here that I'll just copy paste and then paste here. So you can see the pattern shape here. You see the peak here between 7 and 9 p.m. and some other variation. Now let's just add this newly created pattern to our 6 inflows. daily inflow dry weather inflow pattern here. Yeah. Now. Right. We still need to connect these dots to the manhole, so all the water in sewer networks comes through the manholes. So all the leakage, for example, is mathematically inserted in the manhole component in the system, and as well as these customer connections. I can connect these manually by selecting them and right click on a junction and connect selected inflows here. You can do it like that, or you can automatically connect all the inflows to the nearest manholes from Tools menu, Inflows, and Update Inflow nodes. Now you can see these remaining 3 were attached to the nearest manhole. Okay, one thing about sewer models that all the water that comes into the system must have access to a component called Outfall. So it's a component where the water can leave the system. Usually they are located in the lowest ends of the system, and they are used to depict, for example, the wastewater treatment plant or an exit to a ditch or sea or something like that. But I will add one outfall here in the end of my system and connect it with a pipeline. Let's put same material to this pipeline. 160 PVC. And the elevation of this one is in 0 and this is in 2, so it should be okay. And let's just look at the whole line that we have created here. How does it look like? Yeah, it looks okay. And this is the outfall here. Let's put the background map on. Okay, now we should be ready for simulation. On the top level menu Simulate, you will find the Simulate button. You can also activate it by pressing F5. Alright. On the sewer side, you will get a report on the water balance of how much water goes into the system and how much water exits the system, and what is the difference of those. If you don't have a result window open, you can find one under the window Results. You can have multiple of these open as well. Okay, on the bottom result window I have selected Flow. So this window will show the flow in my selected pipelines. So for example, if I take the first one, we can see the flow here. It varies according to the pattern that we have put into the model. And if I select pipeline somewhere here, we can see the flow in that one. It's a bit larger because we had 3 customer connections here. Another interesting thing that we could look at the results would be, for example, depth. So that would be for selected manholes. You can see the depth, how the level of water increases in the system. We can see the results also in the profile window here. We see that the water level is not rising anywhere above the pipe top level. But for example, if we would add more inflow to our system, so now we should see clearly how the water level rises in the system. This dotted line here shows the maximum throughout the simulation. This shows the level at the present time step. Since we are doing a dynamic simulation, we are always playing in a time frame that all the simulations are tied to certain time step. We can look at the result in selected time step by browsing through the time here. For example, now we are at 6 p.m. and you can see this time slider here in the result windows, and this blue as a current level of water at this time step. So with this amount of water we would be having problems, and eventually this manhole here would overflow to ground level. Okay, this was the basic of Fluidit Sewer modeling. I hope you got some interesting pointers here and you are now able to make your own simple models.